I think the side that seems most complicated is the one that has adding and subtracting because that's the most annoying to get rid of. So I tend to start on the side over here because we have two trig functions over here, two trig functions over here. This one's got the subtracting, so I'm going to go over here. So I'm going to take this side. Oh, good, it stayed up. And I'm going to put this side into sines and cosines. So secant, if I want to write that as a sine or a cosine, how would we do that? What is secant? 1 over cosine. Secant is 1 over cosine of x minus cosine of x. What do we need to do to be able to smush them together? Common denominator. So I need to take this piece and multiply it by what? Cosine over cosine. I need them to have a common denominator so I can put them together into one fraction. So we're multiplying it by this denominator, but I can't just randomly multiply it. I have to multiply it by 1. Just a weird looking 1. So that's going to give us a fraction that has a denominator of cosine of x. And we're going to have our 1 minus, what is this one going to be? Cosine squared. So cosine squared x. Remember, when we write it like that, I'm just going to put it over here. Cosine squared of x is the same thing as cosine of x as a group squared. So it means the same thing. Mathematicians don't like parentheses as much as we use them. Like, they would really like it to be able to not have parentheses. So they mean the same thing. So cosine of x times cosine of x is cosine squared x. So we have a goal over here. I want to be able to get rid of that minus sign. Over here, nothing over here has a minus sign in it. So I need something that'll let me get rid of that minus sign. What can we use that'll let us swap something out there? The Pythagorean identity. We're going to need to use one of those. The one we use most frequently, not going to be the only one, but the one we use most frequently is our sine squared theta plus cosine squared theta equals 1. How does this one help us with this? Yeah, if I subtract cosine squared from both sides on this thing, so subtracting our cosine squared theta, we're going to get our sine squared theta equals 1 minus cosine squared. Well, I have 1 minus cosine squared. So we can substitute this piece out for our sine squared. So I can rewrite this as sine squared x over cosine of x. So it's a substitution using the Pythagorean theorem. So now I've gotten rid of that subtraction. We just need to figure out how we get to something like this. Because sine squared, remember, cosine squared is the same thing as if I had cosine of x squared. 2b squared means times itself. So I could rewrite sine squared as sine of x times sine of x over cosine of x. What are we trying to aim for? Yeah, this guy is tangent. This guy is sine. So we're here. We had to have them switch to different sides, and that's okay. We have sine of x times sine over cosine. That's my tangent. And that's exactly what we were aiming for here. Tangent of x, sine of x. So we didn't even have to adjust the right-hand side. We don't have to. There are some teachers who say you can't adjust the right-hand side at all. But we got our left-hand side to match our right-hand side. It doesn't matter if they're flopped, just like it doesn't matter if I do 2 times 3 or 3 times 2. That's commutativity. That's one of those math things that we used to talk about all the time. Okay? So these are things that are just going to take us some practice to do and just like working through stuff. We're going to do one more weird looking one just because it exists in the book. I don't know that it's actually on this year's homework, but it's there and I don't want us to see it and go, what the heck is that? It's going to look scary when I put it up, but I promise it's actually one of the shortest ones today. Okay? Don't panic. I said don't panic, don't panic, don't panic. Okay, I was going to say, sometimes it's in the homework, sometimes it's not, but if not, it's one of the ones next to the homework questions, and I don't want us to panic seeing that either. So, this one's honestly really not long. We do not have to remember much about logs. We do not need to be able to take logs of these. We've got the log of tangent of theta, and that's going to equal the log of sine of theta minus the log of cosine of theta. So I definitely imagine that this side's going to be our more complicated side. So we're going to start with this guy on the right-hand side. What do we remember about logs and like minus signs like that? Come on in. I've got over there. This whole table that's available. A couple spots in front. Okay. So, all right. What do we remember about logs? We're going to look at this side first.
Minus is the same thing as like division.
Yes. We're going to condense this. Pulling that out. Subtraction becomes division. So this is going to be our log of the fraction sine of theta over cosine theta. All right. How can I change the name of this thing? Sine theta over cosine theta? What is sine theta over cosine theta? Tangent. What were we aiming for? Tangent. Our left-hand side matches our right-hand side. Did we need to know tons about logs? No. That's the end of that one. Just don't panic, okay? You good, Justice? Just seeing you giggle. I'm just checking in. I was say Precious is up there too. What you guys good? Okay, you tickled about something. I don't know what happened, but we missed something funny. Okay, so the verifying stuff, we're going to continue to see that. Like, we will have those pop up every now and then, but that's like a majority of the verifying stuff we're doing. The log's probably the most scary looking one, I think, but it's really like super easy once we get there. Okay, so we're going to look at this kind of last bit of 6.2, so 6.2c. It's one of these things. This section contains way too many things in one section. This should have been like 3 sections. But we're going to look at the stuff that's mostly in 6.2c. That's going to require us to remember a little bit. So we're going to kind of jump back and look at a coordinate plane for a second. So before we start looking at things we're going to do here, I want us to remember which quadrant is which. First things first. What's this guy? 1, quadrant 1. Which values are positive in quadrant 1? X's and Y's. So everybody's positive. So if we think about our ordered pairs, x comma y, our x's are using our cosine. We talked about this the other day when we looked at our unit circle. X's are cosines, and our y's are sines, right? So if x's are positive and y's are positive, cosine and sine are both positive, tangent will also be positive. So everybody's positive in quadrant 1. What quadrant is this one? 2. Which pieces are negative in quadrant 2? Our x's are negative. So I'm going to put my negative. X's are negative, which means which trig function is negative? Cosine is negative. Is my tangent going to be positive or negative? Negative, because I have a positive sine, negative cosine. Sine over cosine. Positive over negative is going to give me a negative. So tangent will be negative in quadrant 2. So these guys are all negative. X's, our x values. These guys. All right, so quadrant 2 has negative x values. What's this guy? 3, quadrant 3. What is negative in this space? Our x's and y's. So, which trig functions? Sine and cosine, right? So we've got our cosine and our sine. Is our tangent going to be negative? Because it's negative, so our sine is negative over a negative. Negative over a negative, that's positive. So our tangents will be positive in quadrant 3. So this guy, I don't know why I went that far out. Quadrant 3, these are our values. Okay? I don't like that. That's way too opaque there. We're just going to leave those blue. And then our last quadrant over here, what's this one? 4. We typically do this as Roman numerals. IV. Which pieces are negative here? Our y's. Our x's are positive, but our y's are negative. So which trig functions are negative here? Sine is negative and tangent is negative. So wherever sine is negative, which of our other 3 goes with sine? Sine goes with cosecant. So if sine is negative, cosecant is negative. If cosine is negative, secant would be negative. So sine and cosecant go together. Cosine and secant go together. Tangent and cotangent go together. So whatever the signs are, they're going to match up, because remember, they're just reciprocals of each other. We're going to practice with this a bit. I'm seeing some confused face. Where did I lose you? Okay. So remembering these kinds of relationships is going to be important for one of the kind of sections in, I think it might be in 6.2. I don't remember. Okay. It might be 6.3. I don't remember. I'll have to look. All right. Because the book is going to give us problems that look like these. I'm going to change one of them real quick. Tangent is going to be positive. All right, switching that one. Okay, so we're asked to figure out which quadrant is going to contain the angle that has these trig function values. So it's looking at our positives versus our negatives. So if sine of our angle is greater than 0, is that positive or negative? If the sine is greater than 0. Positive. So sine is positive. Cosine greater than 0. Is that positive or negative? Positive. So if sine is positive and cosine is positive, what quadrant are we going to be in? Quadrant 1. Which we do quadrant 1. We put them in Roman numerals. There we go. Sometimes they're going to give us the ones we wish they wouldn't.
Do we have to put in Roman numerals, or can we just say quadrant 1?
As I was like, if you put like Q1, I'm okay with that. I just don't want us to wind up thinking that it's like the angle is 1 or radians is 1. Like, you gotta give me 1. If you put it in Roman numerals, you don't have to tell me quadrant, because that's the only thing we use Roman numerals for. All right. Sometimes they'll give us the other guys, the weirdos. So cosecant goes with which one? Sine or cosine? Sine. So if cosecant is less than 0, is our sine going to be positive or negative? Negative. Because if cosecant's negative, its reciprocal is also negative, because all it does is flip. On this one, because this was our sine, right? Cotangent, that relates to tangent, though. So cotangent, are we expecting that to be positive or negative? Negative. So cotangent, we typically get made up of, that's our cosine over sine, right? So if I know that sine is negative, and I need the whole thing to be negative, what is my numerator going to be? What's cosine going to be? Positive. Because I need cotangent to be negative. That means only cosine is going to be positive. Because if cosine was negative, tangent would be positive, and cotangent would be positive. Okay? So if sine is negative and cosine is positive, what quadrant are we going to be? Sine is negative. That was this guy. Cosine is positive. This would be in quadrant 4. Remember, cosines are our x values, so positive x values, but negative sine values. We're down in quadrant 4. You can also think of this, if it helps to visualize it a little bit. You don't have to do this part. This is just me kind of showing you. Cosines are positive over here. Sines are negative under here. So we're looking here at quadrant 4. Oop. Maybe. There we go. That guy. Okay, sometimes it helps to think of it like that. Cosines are positive, where our x's are positive. Sines are negative, where our y's are negative. So our bottom one, very similar vibe. Just practicing it again. So cosine greater than 0 means our cosine is going to be what? Positive or negative? Positive. And if our tangent is greater than 0, what is our sine going to be? Can we make the jump? Because I need my tangent to be positive. So that means my sine can't be negative, or I'd have a negative and a positive, so we'd wind up negative. So my sine also has to be positive. So we'd be in quadrant 1 here. Okay? So on the ones where it's just asking us to find the quadrant, that's what we're looking for here. Are my sines positive or negative? Are my cosines positive or negative? I was like, it's a fresh one, so it's a little tight. Okay? So I was like, I know there's a couple of questions like that on the homework. Figuring out which quadrant we're in. I do not remember if it's B or C. I think that's on C. Definitely not on B. Okay. Yeah, that would be like the 85, 87 questions. So that's on C. Questions on these ones?
I was just about to say.
Okay. So our next bit that they're going to give us, that we're going to work with, is instead of them giving us an angle or a trig function, yes, dear? Yes, because cotangent is the reciprocal of tangent. You can do 1 over tangent, but in this case, since we know sine, 1 over tangent won't actually help us because I don't know anything about tangent. So if we knew about tangent, we could absolutely use that for cotangent. And we'll use that sometimes like when we're verifying stuff. We can totally use that. It's just in this case that doesn't actually help me. Okay, so the next thing we're going to do is we are going to look at points. Do you need a notebook, Emrilla? Do you need any paper or anything? Are you okay? Okay, that's fine. It's your choice. I was like, I have some if you need any, okay? All right, so we're going to take a point and be able to find our trig functions on here. We're going to be relating it to the origin, so we're thinking of it kind of like a point on our circle. When the book writes points, they do it like this. They'll put typically a P just to make it really clear that this is a point and not an interval. Are y'all playing Jenga with my calculators over there? No, I was like over there.
Oh.
And we're trying to get a calculator on the top of that, Tyler. Don't break my calculators. Thank you. I was gonna be like, I was like, I get the fidgeting thing. I have options over here. You're welcome to use a fidget. I have several. All right. So I'm gonna put a little sketch over here. I don't know if it's gonna be a size that we like, but we'll see. So if we're thinking about a point that we are given, something like x, y, I know it's super tiny, and we're trying to find the trig functions for them. We're comparing it with our initial position here, and we want to find the trig functions based off of this triangle. I know it's very small. I'll change the view so you can see it a little better. So we're going to look at this kind of triangle. We've got a point with our x and y. We want to be able to find trig functions of this angle that is not showing up. This one. It's always based off of that initial side. If they only give us our ordered pair, which they often will, what that actually tells me is my adjacent side is my x's over here. My opposite side is always going to be my y's. The last thing we need is we need to figure out our hypotenuse, our other leg, this guy here. When we're dealing with it as a point, a lot of times they will write it as r because we're relating this to the circle based around the center. That would be like that. I'm so good at circles. That looks like that. And so it's our radius. That's why they're calling it that. So what this is over here, this equation for r, it's actually the distance formula. It's also exactly what we'd get if we did our x squared, our a squared, plus our b squared equals c squared. It's the Pythagorean theorem. They just did a square root on both sides to get this one to be an r equals. It's still a squared, which is x squared, plus b squared, which is y squared, equals c squared, which is r. They just square rooted both sides. So if we're looking at something like this and we're trying to find our trig functions given this ordered pair, we are still doing the exact same thing. Looking at this angle, we're going to get our sine, opposite over hypotenuse. So we can write our sine of an angle when we're given an ordered pair as y over r. It's the opposite, so as O, opposite over hypotenuse. Opposite over hypotenuse. So it's the y value of my ordered pair over that distance. Our cosine, that's going to be our cos, C-A-H, adjacent over hypotenuse. That's going to be our x over that radius. And our tangent, opposite over adjacent, we're going to have y over x. So from our ordered pair and our ordered pair alone, I can get my tangent. With just a little bit of calculation, I can get the other two. From those three, we can get the others. Because we know that sine and cosecant, they're buddies. They just like to do some flips every now and then. So cosecant is going to be the reciprocal of sine. So it's going to flip it. So we're going to have r over y. Secant, what that one's going to be is the reciprocal of cosine. So that's our r over x. And our cotangent is the reciprocal of tangent. So we're going to have our x over y. So again, the sine, cosine, and tangent are still our SOHCAHTOA. They're still the opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. It's the same pieces. We're just giving them slightly different letters here because we're looking at an ordered pair. You can absolutely build this from our SOHCAHTOA opposite over adjacent stuff. You don't necessarily have to memorize the y over r. We're just going to work with it, okay? So I'm going to give you guys a second to write this down. I don't see anybody still writing, so I'm going to switch it, okay? So we're going to practice with this. I'm going to give you a point. And we are going to find the angles and find all 6 trig functions for this point here. So sometimes it's helpful to give yourself a sketch, sometimes not. But that's okay. I'm going to give us a sketch so we can see what's happening here. What quadrant is this point in? Quadrant 2, because my x's are negative, my y's are positive. So we'd be at negative 15, positive 8, up over here. When we're looking at this, and we're looking at our x's and our y's, this is giving me this side here as negative 15, and this side here as positive 8. We need to know what our r is here. Even though we're in quadrant 2, and we're technically looking at this angle, we're using this coterminal angle here as the angle that we're staring at. So it's this little inside one here. It is always going to be the one that's at the origin. Always. Every single time it's at the origin. That will always give us that x is our adjacent. Every single time, x is always our adjacent. Y is going to be our opposite. Every time. So y is always the opposite piece. So even though we're over here, all it does is play with signs. It's the exact same triangle as if I reflected it over the y-axis. It's the same triangle. It's just the sides are different. So we need to know what that r is, what our radius is, to be able to do all of our trig functions. So we're going to do our distance formula, or Pythagorean theorem. They're the same darn thing. It's just one's got the square root and one doesn't. They're the same formula. So we're going to take our x, that negative 15, and square it, plus our 8 squared. So what is negative 15 squared? 225. What is our 8 squared? 64. So you thought 9, but that's okay. Just make sure we're slowing down when we're doing homework stuff. 225 plus 64? 289. What is the square root of 289? 17. So our r, our radius here, is 17. Now we can get all 6 of our trig functions. Okay? We're going to get our sine, cosine, tangent, all those jazz. So we're going to find sine of, and we can put theta, since that's what they called this angle in the story. If they don't tell you that, you can put sine of that point. I'm okay with that notation, totally fine, sine of p. I'm just going to put it as theta since they actually gave us that. You can also pick theta or x. I wouldn't recommend x because we're using x's. But you could do theta of a variable there. We just typically use Greek letters for angles. So sine of theta is going to be what? Yeah, it's our 8 over 17. And it's our opposite over hypotenuse. So we can do it on the triangle as well here. So our cosine of theta is going to be, yeah, our negative 15 over 17. And you can have the negative with the 15, or you can have the negative out in front. I do not care. Whether your negative's in the numerator, denominator, or out in front, they all mean the same darn thing. I don't care. Tangent is going to be what? Yeah, so we're going to have our 8 over negative 15. And again, you can have the negative with the 15, or you can have it out in front. From here, we can get our other pieces. Sine goes with which one? Cosecant. Each pair only gets one co. Cosecant goes with sine. So cosecant of theta is going to be what? 17 over 8. It's always the reciprocal. 17 over 8. So cosine goes with which one? Secant theta, which is going to be 17 over negative 15, or negative 17 over 15, or of the negative out in front. I feel like the negative out in front is kind of the most universal. It makes it hurt your brain less. But whatever floats your boat. And tangent goes with which one? What's our last option? Cotangent. And what's cotangent going to be? Yep, negative 15 over 8. And again, I don't care if your minus sign is in the numerator, in the denominator, or out in front. I don't care. It does the same thing. Okay. Questions on this one? Okay. We're going to keep working with these some more tomorrow, but honestly, this is how far I got in yesterday's class, or in the previous class, and it's so much easier for me if y'all are on the same page, because then I don't have to remember which pages I erased or not. So what I'm going to do is I'm going to pass back all the homeworks and things we've got. If you guys have questions on anything, please let me know. Just stop me as I pass stuff out. I'm going to pass back all the homeworks I have. Everything should be in. And tomorrow we'll finish up 6-2. I'll get you the review for the quiz. All that jazz. So, here's this stuff. Let me get these passed back to you guys. Yeah, there's tons of them up there. Tomorrow we'll be able to finish up 6-2C, and I'll show you guys a couple of unit circle filling in technique options. So we'll have time enough to do that tomorrow. I think we only have like 4 or 5 problems left, but I just I was going to say, everything is in on campus as well as Skyward. So, yeah. Double check that things are incorrectly before you throw things away. It just makes it easier. That's why we have to double check.
Wait, what's wrong?
Wait, there's already started on your teapot today?
Oh,
Yes. What?
I'll do I do my work in the morning. I did my journal. I didn't want to do that.
Yeah, you
I don't know how to form the
I wanted to get on the wheel today, but yeah. I wouldn't do that anyway, because at one point I'm gonna have to make
something
something.
about
And like if I wait till last minute, I won't be able to learn how to do it. Yeah, and you're like, more stuff like that. I don't know how to. But by the end of the semester, we have to make a rug or a.
Secant is related to
On the
which
wheel, but it has to be like something of that dimension. Like the bottom of the one has to be 30
So we're gonna
inches,
use
but it
one
has
of
to go
our
out.
Allen identities, very much like how we did,
Yeah.
for the,
And same with the
Ah,
mother. Same with the mother. I think it's like 3.
so, on this, remember how we solved this one to be a sine squared equals? I could solve this down to be a sine equals by square rooting both sides. So on this one, we are trying to get sine equals, or we're trying to get sine to be made out of secants. So we're going to use one of our trig identities, and there's one of them that has secants in it that we can use to kind of adjust that around. Okay, so we're trying to find which pieces we can use. Okay? What's up?
we're so confused on this one, 33.
33. You took a radian angle and tried to convert it to radians. Okay, whatever's on the top is what you're putting it into. So you took radians and tried to make it radian.
It's actually made into degrees.
It 2 degrees to get that. And then the second part was to do our area. Because there was a part B to find your area, to use the area formula. Okay?
Yeah. Thank you.
Yep. And there's a little bit more.